As AI moves from experimentation into production, organizations run into a new set of problems: inconsistent behavior, unpredictable performance, and costs that are hard to control. Those problems only get solved when AI is operated like an enterprise infrastructure, not a side project. That becomes especially clear in financial services, where AI just doesn't answer questions, it interacts with regulated client data. Here, we're using an embedded advisor assistant inside a wealth management portal. It's powerful, but without guardrails, it's also where things can go wrong. First, a normal expected use case, summarizing client portfolio details the advisor is already viewing. Now watch what happens when someone asks the assistant to recommend specific stocks. Without guardrails, the assistant drifts beyond its analytical role and begins acting like an authorized financial advisor. It's a natural prompt, and it's exactly how AI ends up delivering unapproved financial advice in production. Now, let's enforce those boundaries. We're not changing the application, and we're not retraining the model. We're applying security guardrails in transit. Same advisor, same client account view, same prompt. This time, the assistant refuses and explains why. This is enterprise AI security. Define the role, enforce the boundary, and make behavior predictable before AI ever reaches advisors. Once AI behavior is governed and safe, the next challenge shows up immediately: scale. This isn't a single advisor, it's hundreds of advisors and service reps sharing the same AI service. At that point, performance stops being about requests and starts being about how fast tokens are delivered. On the right, you can see the LLM backends and the signals used for routing. Right now, routing is based on traditional server response time. The request goes to the fastest responding backend, the response comes back, and everything looks fine. This is what most AI integrations look like today. Now, backend conditions change. Response time still looks acceptable, but token latency has increased. Same prompt. Because we're still routing by response time, traffic keeps going to the backend that looks healthiest, but unfortunately, it delivers tokens slowly. This is where traditional load balancing breaks down with AI. But what if we route traffic based on LLM token latency? Same user, same request. This time it's routed to the backend that can deliver tokens faster. Nothing about the request changed, only the routing signal. AI-aware load balancing keeps performance predictable at scale because it optimizes what users actually feel. But performance alone isn't enough. When AI becomes shared infrastructure, you also need enforceable controls so one user or workload doesn't consume everything. Unlike traditional applications, AI is billed and limited by tokens. Every prompt and every response consumes them. Here's the first control problem. When AI is shared, one user or an internal automation can consume a disproportionate number of tokens. This is no longer normal human interaction. It's high-volume, repetitive usage that would eventually degrade the experience for everyone else. Fair use policies enforce token consumption per identity over time. And when a user or process exceeds their allocation, that identity is throttled. Everyone else continues without delay. This is precise enforcement. Contain the offender, not the platform. This is a user limit, but we also have limits on the LLM model. Even paid AI services enforce caps, daily budgets, per-minute limits, or model-specific quotas. In production, you don't want those limits to turn into user-visible outages. That's why we run a more powerful primary model and a less expensive fallback model. When the primary hits its cap, you automatically spill traffic to the fallback LLM. No failure, no manual intervention. The service stays online. That's continuity. Limits are enforced, but advisors keep working. This is what it looks like to operate AI effectively. Security defines what the AI is allowed to do. Performance ensures it behaves predictably at scale. And control makes sure usage stays fair, costs stay governed, and limits never turn into outages. That's when AI stops being an experiment and starts operating as a reliable, enforceable enterprise service.